But let me begin with what it is, so you have some context.
Mast begins with a simple idea. Manage both your work and personal communications on a single device, and do it all using the standard iOS phone and messages apps. Mast invisibly and intelligently uses the right number depending on who you are calling. You have an ultra-simple app that puts you in complete control of your two numbers and your contacts. Let's take a look at how it works. Your work and personal numbers are both normal mobile numbers, and each has its own group of independent settings. The dashboard gives you access to the most important ones. Mast uses your default number, which you can change whenever you like, for calls to new contacts or to numbers you haven't called before. If you want to leave work at the office, simply enable Do Not Disturb on your work number when you're on your way out, and turn it off again in the morning. The same goes for your personal number. Mast intelligently marks many of your contacts for you and makes it easy for you to fill in the gaps. Just swipe to mark a contact work or personal, and we'll do the rest. It's important to use the right number when you make a call, but it's just as important to know which number you're being called on. We create a number ID so you'll know if an incoming call is work or personal before you pick up.
That gives you an overview of what it is that we've built, okay? And the reason I showed you that, just so you have context, and so that people realize that what we haven't built is an app that you do voice calling through, right? The app that you just saw is basically managing the service, but all of the calls that are happening are we are a mobile carrier, and all of those calls, all of the messaging is happening as it would with an AT&T or a T-Mobile or whatnot, okay? Now, what's interesting about that, of course, is the name of this talk originally was Building a Mobile Operator in a Year, more or less. It started like this. It was three co-founders. I'm one of the three. We had no team, no software. We did have a nice slide, and that's kind of what started it all, including in a meeting room over here. And then from that, very quickly, I had to kind of go down the path of trying to figure out how to go build this thing. Which seemed fairly daunting at the time, to be honest. And I'll give you kind of an overview of the architecture, talk about it a little bit, and how I got the different pieces going, okay? And then after that, Alex will double click on one of these pieces and kind of the interesting kind of complexities that we have. So if you look at our architecture right now, we have over here, we have kind of the mobile applications, the iOS app you just saw in the demo, the web experience. There's a piece over here which is traditionally the middle tier, surfaces all the APIs. That is a piece that we actually ended up licensing the software of that piece from a third-party company that had already built a piece that had already built mobile management software, expense management software, for 5 or 6 years. They were a software company, and so it was kind of interesting that we were able to license the software from them. But we kind of wrote it into the contract not to compete with them, and limited our use of that software. But we were okay with it. So we got one piece that way. We got one piece. The kind of billing and rating is a big deal for a mobile company, obviously, because if you think about every call, every SMS, every piece of data that goes through the phone, that stuff gets sent to us, and then we have to basically rate it. There's different taxes, there's different, you could be roaming in a different country. There's a ton of stuff that has to happen. It all has to happen correctly, or the final amount at the end of the month doesn't work. So that is the one piece that I basically licensed a closed source piece of software. And I can tell you what these things were later after a beer. I'm not going to do it while I'm getting recorded. and then the kind of, in some respects, the very interesting piece is this piece right here, which is the networking piece that actually handles and is in the path of phone calls and SMSs. It's not in the path of data right now. We could be in the future. But right here, what we have is, in essence, our first mobile operator partner. And so whenever you make a call from the phone, it goes through the mobile operator and into this stack. There's a bunch of pieces to the stack, like an SMSC that we built, which is the piece that talks SMS with the carrier. And kind of on the other side of this is the world of communications, right? So think of it as the PSTN, which is when you dial a phone number and it actually ends up ringing another phone. that, or you might end up, I don't know, at a Skype terminal, right? Because they have a phone number as well. And then if you look at kind of what those are, the middle tier that we licensed and built kind of an orchestration layer around to make all of these things work together seamlessly is built in Ruby. The licensed piece of software that does all the rating and knows how to do a lot of rating for carriers in Europe is an Oracle product. But kind of the core of the networking stack is built in Erlang, which I'm curious, actually. How many people have heard of it or know about it or use it? OK, a lot. Cool. All right. So yeah, super interesting language, actually. Originally built by Ericsson for software switches, open sourced, and now in use by a few people, WhatsApp, including, and also us. And that's the piece that Alex is going to talk about. The interesting part about that is that when you look at the setup that we actually have two of them. We have an East Coast data center running this stack, and a West Coast data center running this stack. This piece can actually communicate to one or the other. Actually, it could communicate to, you could round robin, it could do whatever. Right now, it really just talks to one. And the mobile operator will talk to both depending on kind of location. So if I make a phone call right now to you, it will actually end up at the East Coast data center for us because that's closest, right? If you're in San Francisco, it would end up at the West Coast one. But the interesting piece, of course, is that all of the system has to act as one from our perspective, right? So I'll give it to Al. Did I forget something? No. No. OK, good. Exactly. So she'll double click. Oh, I did forget something. So if you look at this and what's in this Erlang stack, there's a bunch of components in here, like I mentioned before. There's an AMQP bus that basically makes them all communicate. And then a big part of keeping all of this working as one system is CouchDB, which is a document-based, NoSQL-based database that knows how to do kind of replication across geographies, et cetera. And that's the piece you're going to focus on exactly kind of how we use that in detail, specifically in the scenario you saw in that video. Cool? All right.
Cool. So I'm Alex. And as Dave said, I'm going to dive in a little bit deeper on how we handle redundancy. So as he said, CouchDB is a NoSQL open source data store. It exposes an HTTP interface. It stores or manages collections, which you can think of as databases of JSON-based documents. One of the really cool things about it is that it allows quick lookups via these things called views that work via MapReduce. And I'm going to talk about how we use it. So as we mentioned, we have two. And this lets us have redundancy. And I'm going to talk about why redundancy is important for us, what complications redundancy adds, and how we deal with them. So why is redundancy important? Well, as he mentioned, it lowers latency. When you make a call, talks to the East Coast rather than the West Coast, that's less latency in the call path. It also ensures reliability. Say the East Coast goes down. I still want my call or my SMS to make it through, so it can get handled by the West Coast as well. The same is the case for API requests made by our orchestration layer. So what complications does redundancy add? Consistency. And I'll get back to that in a moment after I go back to talking about our needs. So just to zoom in on one small problem, that's contacts management, which is one of the main things the video focused on. So if I make a phone call, it goes out from one number, and we handle the call, and on the fly, we need to look up which number the call should go out from. And if I've never talked to Dave before, and I have nothing saved for his number, and he calls me, before the call makes it to my phone, we want to save on the fly that Dave called me on my work number. It was a cold call. Next time I call Dave back, it should go out from my work number, because that's the number I talked to Dave on. But we also allow users to update these preferences. So go back to that video in the app, someone can swipe between work and personal so that this preference is updated, and next time I call Dave, it'll be calling out from personal instead. And that's a case where, as previously, we are writing a small amount of data. But we also need to support bulk uploads. So when a user logs into the iOS app for the first time, we want to be able to sync the contacts book. That's a big bulk upload of data. And we also let users see and manage their contacts via the web interface, and that's a large get of data. So we have a lot of ways our users are managing their contacts. And before we jump into the problem, who here has heard of the CAP theorem? Yeah, so most people are familiar with the CAP theorem. For the people that aren't, I'll just jump through it really quick. So CAP stands for consistency, availability, and partition tolerance. Consistency means that no matter which data center we're talking to, it's the same data. So it doesn't matter who I'm reading from, I should get back the same response. And that response should be the most recently written data. Availability means that I always get a response in a reasonable amount of time. Even if one data center is down, I'm still getting a request responded to reliably. And this is really important for us because at the end of the day, we're trying to deliver a reliable phone service. We can't handle not responding to another mobile operator's request for a phone call. And then partition tolerance means that if the network connection somehow goes down temporarily or permanently, we need to be able to continue functioning. And in a perfect world, network partitions never happen. We have perfect networks and wouldn't need to even consider partition tolerance. So what the CAP theorem actually states is that you can only have two of these three. You can only have two of the consistency, availability, or partition tolerance. It's impossible to deliver all three in simultaneously deliver all three in a distributed system. And in case that doesn't make sense to you, just imagine the case where a request comes in, we can't respond to it unless we know that the data is correct. But we have to respond to it. But at the same time, we're dealing with a network partition, and so we don't even know if the data is correct. It's impossible to handle all three. So that means we can only choose two. But in reality, network partitions happen, and we have to take P as a given. We have to deal with partition tolerance, so it means we only get to choose between consistency and availability. And that's tough for us because we want both. We want to be able to let users manage their contacts, for example, and have it be a reliable user experience. But at the same time, we need to always deliver with availability. But we can at least balance these needs. So when the UI syncs with our service, sometimes it's a large amount of data. It should always be consistent, right? Like, it would be a jarring user experience if in the web interface or the iOS app, you think you switched a contact to be one way, and then you call out, and you're calling from a different number. So we want to deliver consistency. But at the same time, when we need to handle calls on the fly, we must choose really quickly which number to use. And this involves reading a really small amount of data. And we need to deliver with high availability. So in this case, we choose high availability. And we've done a little bit more to make a point of using views so that we can really quickly look up a very small amount of data, even though a user's contacts, the actual documents might be much larger. And then take this one step further. So we need our core platform, which is our platform that processes calls, to be really safe. We need to be protected from potential load. And the types of bulks, read and writes that the app can produce could potentially put a large amount of load on our system, and that could slow down requests that the real-time call is trying to make, which is not acceptable. So we have to handle like many users logging into the app all at the same time for the first time and syncing like 3,000 contacts at once per se. So we decided, well, we can break this up. So for the UI, we can have a secondary data store that handles all of our API requests. And that we want to be consistent, which means that we only respond after the data has reliably replicated and we know it has written. And in that case, we can ensure a higher write quorum for that data store. And then for our core platform, we want our core CouchDB to be really close to our call processing service so that the lookups and the writes can be really fast. We can make writes asynchronously because it's not as important that they're consistent. And we can have a lower read quorum. So, and then it's isolated from the API requests and safer. So that's how we think about delivering with both availability and consistency balanced. And if you're tired of your old mobile operator, you should consider transitioning to Mast as your carrier.
And maybe one last thing. So one of the things that we do through this is give you the ability to have a work number and a personal number. But what you should think of this is kind of as, we think of ourselves as the first software mobile operator, right? Because what we've basically, because now that we have, think of it as, open source, off the shelf, with some closed source that we're proud of. But in essence, it's software that's handling your communication. And we know, based on what we've done here with your contacts, what is business, what is a business communication, and what is personal communication. Which means that on the personal side, we can keep things private, but on the business side, we can actually do really interesting integrations. And in essence, expose that data as a platform for integrations. So one of the things that we do is we approach businesses and sell this package in a way where we can integrate seamlessly for sales guys, for example. Sales guys have a problem, right? Whenever they communicate to a client, their manager is all over them about making sure that what they've done in that communication has been logged in some CRM system, typically like a Salesforce. We can automate that for them, right? Because if you think about it today, when you communicate with T-Mobile, really the only data you get back from T-Mobile is a bill, right? You can't extract any other data. What we're basically doing is surfacing communications as a platform on your mobile phone and doing so kind of differently for the work side versus the personal side. Whether we should do it on the personal side as well, I don't know. I'm up for discussion. Let me know what you think, but seems like it could be interesting.